Our changing Earth. Look at the given world map carefully. You will probably observe that the shapes of the continents have a familiar pattern. The eastern coast of South America can probably fit into the western coast of Africa. Similarly, Australia can fit near the Indian landmass in the gap which is now filled by the Bay of Bengal. What seems to emerge is that earlier all continents were clustered together as a supercontinent called Pangaea, which is actually a Greek term meaning all Earth. The theory of Pangaea was first proposed in AD 1915 by Alfred Wegener, a German meteorologist. The 7 continents which exist now have come into their present shape over a period of millions of years as shown in the figure. Earth movement. The crust of the Earth is broken into a number of large and small plates known as the lithospheric plates. There are 7 major lithospheric plates which move extremely slowly. This is called plate tectonics. The movement occurs due to the heat generated by the molten magma inside the Earth, which moves in a circular manner. These movements, which are called tectonic movements, cause changes on the Earth's surface. On the basis of the forces which cause them, these movements are named as endogenic forces and exogenic forces. Endogenic forces act in the interior of the Earth, leading to earthquakes, volcanic eruptions, and landslides. Exogenic forces work on the surface of the Earth, and their effect can be seen in the form of erosional and depositional features of wind, water, and ice. The movement of the lithospheric plates can either be slow or sudden. Slow movements result in the formation of mountains, while sudden ones cause earthquakes and volcanic eruption. But in all these 3 changes, one thing is certain, that if they occur suddenly, they can be disastrous for life forms and properties. Volcanoes. A volcano is an opening in the Earth's crust through which molten magma or lava erupts suddenly. This lava accumulates and forms a conical hill or a mountain with a funnel-shaped depression opening at the top, which is known as a crater. As eruption takes place, the erupted material accumulates around the crater and forms a conical hill known as a volcanic cone. These eruptions can either be explosive or quiet. An explosive eruption occurs through a narrow vent and lava accumulates around the crater, forming a conical shaped hill like Mount Fujiyama of Japan and Mount Vesuvius in Italy. The quiet eruption results in the formation of plateaus like the Deccan Plateau. In such eruptions, lava oozes through several narrow cracks and spreads over a large area, forming lava sheets. Types of volcanoes. Depending upon the frequency of eruption, the volcanoes can be classified as active, dormant, and extinct. Those volcanoes which have erupted frequently in the recent past and have the possibility of further eruption at any time are called active volcanoes. Mount Etna in Italy and Barren Island in Andaman Islands in India are examples of this type. Certain volcanoes which have not erupted for a long period of time are called sleeping or dormant volcanoes. Mount Vesuvius in Italy is an example of a dormant volcano. Volcanoes which have not erupted for several thousand of years and do not show any possibility of any eruption in future are termed as extinct volcanoes. They are also called dead volcanoes. Mount Kilimanjaro in East Africa is an example of an extinct volcano. Earthquakes. Sudden vibrations caused by the movement of lithospheric plates are called earthquakes. These vibrations are called seismic waves, which travel over a large area. The point where the earthquake originates inside the Earth's crust is called the focus, while the point on the Earth's surface just above the focus is called the epicenter. Vibrations travel outwards from the epicenter as waves in all directions, causing vast damage. The scale of damage caused by an earthquake depends on the intensity of the earthquake, nature of the region or topography, human structures and its quality, etc. So, the damage can be more or less dependent on many factors. The maximum damage is always caused near the epicenter. Earthquake tremors are recorded by an instrument called the seismograph, and their magnitude or intensity is measured on the Richter scale on a scale of 10. Earthquakes which measure 7 or more on the Richter scale are considered of high intensity and cause large-scale destruction. Although earthquakes cannot be predicted accurately, yet their impact can be minimized by adapting certain preventive measures. Degradation and aggradation. The surface of the earth is continuously undergoing changes. Running water, moving ice, wind and waves are the agents of gradation which constantly wear down the land surface and carry the broken fragments which are deposited in low-lying areas. The process of reduction of height of landform is called degradation, while the process of depositing the eroded fragments is called aggradation. Degradation and aggradation are the two ways which are continuously at work creating different landforms on Earth's surface. Weathering takes place as rocks are broken down into progressively smaller pieces by the effects of weather. These pieces do not move to a new location. They simply break down but remain next to one another. It is the most common at the surface where exposed bedrock meets the atmosphere. However, it can extend many thousands of feet downward into the Earth's crust following cracks, fissures and microscopic holes that allow water to penetrate. Erosion. The removal of outer layer of rocks in the natural environment is called an erosion. The major erosional agents constitute wind, water or ice, downslope creep of soil and burrowing animals. This process is different from weathering, as weathering is the process of chemical or physical breaking down of the minerals in the rocks. Work of rivers. Rivers are the most important agents of degradation. The work of the river depends on two factors: the volume of water and the slope of the riverbed. As the river flows through mountainous regions, it has great erosive power.
Two common features formed by rivers are the I-shaped valley and V-shaped valley.
Deep, steep-sided valleys are called gorges or canyons. When the river tumbles at steep angles over very hard rocks, it forms waterfalls where the water plunges down from a great height. Waterfalls have great value as they help in generating hydroelectricity.
As the river enters the plains, it forms curves and large bends or loops called meanders.
As the river enters the plains, It forms curves and large bends or loops called meanders. In due course, the meanders become wider due to constant erosion and deposition along the sides. When the loops become too sharp, the meander cuts off from the main river, forming a lake called the Oxbow Lake. As the river flows along with increased volume of water, it often overflows its banks, causing floods in the neighboring areas. This leads to the deposition of layers of fine sediments along the banks, forming flat, fertile floodplains. The slightly raised riverbanks are called levees. As the river approaches the sea, it moves sluggishly. Due to the load of sediments it is carrying and because of the flat gradient, it is forced to deposit it near the mouth. The river begins to break up into a number of streams called distributaries. The network of distributaries forms a triangular shaped feature called the delta. This is one of the most fertile area in the course of a river. Not all rivers form deltas. Those rivers which flow through steep hard rock areas make a single mouth entry into the sea or do not get divided into a number of streams. The river then plunges into the sea, forming an estuary. Work of waves. Work of waves can be best seen in the coastal areas. In areas where the waves strike the rocky coast, an almost vertical wall of rock is formed by the erosive action of waves. These are called sea cliffs. When sea waves strike continuously at the rock, cracks develop which gradually become wider and larger, creating hollows in the rock.
These hollows are called sea caves.
Over a period of time, only the roof of the rock remains, giving rise to a feature called sea arches. As erosion continues, the roof too collapses, leaving only the walls. These are called stacks, which further get eroded to form stumps. The depositional action of these sea waves result in the formation of beaches. The sand, gravel, and pebbles brought by the waves are deposited in the coastal areas, forming lovely beaches like the Kovalam beach and several other beaches of Kerala and Goa. Work of ice. Glaciers or rivers of ice, as they are called, originate from snowfields in the high mountain areas of ice caps in the polar regions. A glacier can erode, transport, and deposit the eroded materials. A glacier can modify and even completely change the landforms. The erosion work of ice results in the formation of U-shaped valleys, which are deep and have steep sides. As the ice melts, the hollows created by glaciers get filled with water, forming lakes in the mountain region called glacial lakes. The big and small rock pieces, silt and sand get deposited due to the slow movement of the glaciers. These deposits are called glacial moraines. Work of wind. Wind action can best be seen in the desert areas. Features like sand dunes and mushroom rocks are formed due to the wind action. It is the wind which acts as an agent of erosion and deposition which forms these features. Strong winds erode at the base of rocks faster than the top. Gradually, the base gets eroded from all sides, leaving a narrower base as compared to the top. The shape resembles a mushroom, and such rocks are called mushroom rocks. These rocks are commonly found in the Sahara Desert. As the wind blows with great velocity, it carries sand particles with it. When its speed decreases, it drops and deposits the sand in low hill-like structures called sand dunes. Sand dunes are hills of sand most commonly found in desert. A crescent-shaped sand dune is called a barchan. Winds carry the fine dust particles to far off areas and deposit them in humid regions over a large area as loess. Extensive loess deposits can be found in China, the Pampas region of Argentina, and the Mississippi basin of USA.